Hi everyone, this lesson is on finding identities. So we're going to be practicing a lot of identities. So let's get started. This was a red station, and so we are going to prove that this left side is equal to the right side. And so in doing that, we're going to start off and set cosecant to its reciprocal function, which is 1 over sine of theta. And this one right here, which is 1 over cosine of theta. And our objective is to make that equal to cotangent of theta. So we're going to keep simplifying the left side until the right side is equal to that. So this line right here does mean divide. And so we are going to have 1 over sine of theta divided by 1 over cosine of theta, which is 1 over sine of theta times cosine of theta over 1, for which case I have cosine of theta over sine of theta, and that equals cotangent of theta, and that's what I'm trying to prove. And so I'm going to box that up. I got these equal to each other, and we're done with this. Now, some people do like to write this value here as they're going through, which is completely fine. I tend to just write it the last step, but you're welcome to write it every step. So for this one, we are going to try to show that this value on the left is equal to this right, and these are what identities are. So for this one, we have tangent of theta, so that's going to be sine of theta over cosine of theta divided by sine of theta. And in this case, this is over 1. So we're going to divide. This line here means divide. So that's going to be sine of theta over cosine of theta divided by. Now division is the same as multiplying by the reciprocal. So I'm actually going to skip a step here and multiply by the reciprocal, which is 1 over sine of theta. Sine of thetas are going to cancel and make 1, and they're dividing out. And now I have 1 over cosine of theta. Now 1 over cosine of theta is actually secant of theta, and that's what I want to prove. So these are like mini proofs, and we're just proving the left identity is equal to the right side. So now this one's a little bit trickier, okay? We're trying to show that 2 minus cosine squared of theta is equal to 1 plus sine squared of theta. Now, a couple of things that you can think about. Is that you have 2 minus cosine squared of theta. Hint, you can use our super famous Pythagorean identities if we want. And what I'm going to do is I'm going to just choose to replace that value right here with one of my Pythagorean identities. Remember this one, sine squared of theta plus cosine squared of theta is equal to 1. Well, just for cosine squared of theta, if I just isolated the cosine squared of theta, I'm going to get 1 minus sine squared of theta, okay? This right here, I'm going to replace that right there because that's what cosine squared is. So we're going to get 2 minus that value. So it's a quantity, 1 minus sine squared of theta. Now, I'm going to distribute this negative sign. I'm going to get 2 minus 1 plus sine squared of theta. Well, 2 minus 1 is 1. So now I have 1 plus sine squared of theta, which equals this, which is 1 plus sine squared of theta. So I've just proved the left side does equal to the right side. The next one is basically, for this one, we have sine of theta plus sine theta times cotangent squared of theta, and I'm trying to make it equal to cosecant of theta. We have a little hint here, but just see that the sine of theta is common between both of the left side terms, in which case I am going to factor out a sine, so I could factor out sine of theta. What I have left when I factor out sine theta out of sine theta is 1, plus this will cancel it out, and we'll have cotangent squared of theta. Now, from our Pythagorean triplets, what we do know is that we know this. We know that, or our Pythagorean identities, we know 3 of these. We know sine squared of theta plus cosine squared of theta is equal to 1. we know 1 plus tangent squared of theta is equal to secant squared of theta. And we also know that 1 plus cotangent squared of theta is equal to cosecant squared of theta. Well, this is right there. So I'm going to replace this whole thing right here, which is 1 plus cotangent squared of theta, with cosecant squared of theta. So now I have sine of theta times cosecant squared of theta. Now, let's see what we got here. We've got sine of theta times cosecant is 1 over sine squared of theta, okay? And with this one, it looks like I can cancel out 1 sine of theta with one of those, because sine squared is actually sine of theta times sine of theta. And what I'm doing is I'm canceling one of those out, which means I still have 1 times that, which is 1 over sine of theta, and 1 over sine of theta is cosecant of theta, and that's what I'm trying to prove. Okay? Purple station, we're trying to prove that the left side equals to the right side. If I am looking at this right, doesn't that equal sine squared of theta? So what I'm looking at is to get the left side equal to sine squared of theta, because then that'll equal 1 minus cosine squared of theta. So simplifying the left side, we're going to change everything to sines and cosines. So we have sine of theta times cosine of theta, and tangent I'm going to replace with sine of theta over cosine of theta. It looks to me like we're going to divide cosines out and make 1. We're left with sine times sine, which is sine squared. Theta is equal to, and now we have sine squared, which is 1 minus cosine squared of theta, and that comes from square root of theta, and that comes from our Pythagorean identity that said cosine squared of theta plus sine squared of theta is equal to 1. Alrighty. Simplify this. Now there's no equal sign, so I'm not trying to make the left side equal to the right side. What I am going to do is just try to simplify this as much as possible. And I do notice that I do have cosines common in both this term and this term. So I am going to factor out 2 of those. So I'm going to say cosine squared of x, and what I have left is sine squared of x plus cosine squared of x. Now, this right here is actually just 1, so I have cosine squared of x times 1, which is just cosine squared of x. That's simplified. So that was our journey for finding identities, and I hope that helped. Thank you for watching.